So you will see the MCQs related to entropy and lattice energy and enthalpy change in this part. You will use a chat to answer the question, and after each question, I'll give an explanation. So which equation represent the standard enthalpy change of atomization? The term atomization means when we produce 1 mole of atom in a gaseous state from the element in their standard state. So what is the standard state of iodine? Iodine at room temperature is solid. So means iodine must be solid. And we want to produce atom of iodine in a gaseous state. So how many? We need a half mole of iodine, which is in a solid state, and we produce iodine atom. So that's why A is the right answer. Which equation represent the second electron affinity? Second electron affinity means when the second electron is added. So already oxide ion is there and the second electron is added, and it should be in a gaseous state as well. So oxide ion is there, another electron is added. So that's the second electron affinity. So A is the right answer for this. The question is, which compound has the greatest covalent character? Covalent character means which will cause more polarization. Remember one thing, like the things which the polarization it depends on. It depends on the size of the positive ion, should be small. It depends on the charge on the positive ion, should be large. It depends on the size of the negative ion, should be large. And it depends on the charge of the negative ion, should be large as well. So these all will increase the polarizing ability or cause more distortion or have a greater covalent character. So when we compare the size, first the charge of the size of the positive ion should be smaller. So when we compare the size of the positive ion, so we have magnesium is there, which is 2 plus, and we have calcium also 2 plus. Magnesium is top of the, like above calcium, so it means magnesium ion will be smaller. So we ignore calcium, like A and B cannot be an answer. So magnesium is smaller. Then we check the negative. So the charge is same, plus 2 is there. So that's why we compare the size. So the smaller is magnesium. Then we compare the size of the ion. They have the same charge. Bromide and iodide belongs to group 7. So both are -1. But the size of a iodide ion, as we go down the group, the size increases. So bromide ion is smaller in size, iodide ion is larger in size. So as a result, the magnesium iodide will have a greater distortion or greater covalent character, or you can also say will have a greater difference between the theoretical and the practical value of the lattice energy. Some thermodynamic information is shown for reactions W, X, Y, and Z. And remember, if the total entropy is positive, the reaction is feasible, okay? And the total entropy is the sum of system plus the surrounding. And when we simplify, like the total entropy of the system, and what is surrounding? Surrounding is minus delta H over T. When we simplify this, like we take T as an LCM, so T will be an LCM. So this will become T delta S system and minus delta H. That is the total entropy. Okay, so this is the equation for us. Which of these reactions are feasible at 298 Kelvin? Like the one which give a positive result, that will be feasible. If the total entropy is negative, that won't be feasible. So you have to select which reactions are feasible. You have the equation that this T delta system minus delta H over T will give us a total entropy of the reaction. The first option for a W, what they say, the delta H is a negative, and with a large negative value, then means, and this is negative as well. And delta H itself is negative. If delta H is negative, so means this will be negative. Negative, negative will become positive. So this will become T delta system plus delta H over T. And then they mention that the delta H has a larger value. So this has a larger value and this is negative, like this is negative, but this value is smaller. So definitely when I solve them, like a minus, if I say this is -2 and this is +10, so -2 plus 10 will give us +8. So means I'll get a positive answer. So in case of a W, I'll get a positive answer. So means W is feasible. So this is feasible. When we check X, the second one, we check the value for X. So for X, they said the delta H is a negative. So if the delta H is negative, so minus negative, negative will become positive. And the product of T and delta system is also positive. So means definitely this can never be negative. So this will become like this sum will always come out positive. If the sum will always come out positive, it means this reaction is also feasible. So W and X both are feasible. But what about Y? When we check for the Y, so the delta H is a positive. So delta H is a positive. If delta H is positive, this will remain like this with a smaller value. So this has a smaller value, and if the delta H is positive, this will be subtracted. So this value is like the delta H is having a higher value and this product is having a smaller value. Let's say this is 2 and this is 8. So 2 minus 8, what we'll get? We'll get a negative answer. If we get a negative answer, what does it mean? It means that this reaction will not be feasible or thermodynamically not possible. Same thing when we check for the last one. Delta H is positive. So delta H is positive, this will remain like subtracted. And the product of T and delta system is also negative. So when both are negative, we'll always get a negative answer. So it is impossible to get a positive answer. So Y and Z are not possible. That's why B is the right answer. Is it clear, this one?